Lesson 17.2, Task 1, Two-Way Tables and Probability. Investigate two-way tables. A two-way frequency table gives frequencies, counts of people or objects based on two categories. For example, the two-way frequency table from the Spark Your Learning gives frequencies of voters based on their location and how they voted on an initiative. A two-way relative frequency table shows relative frequencies instead of frequencies. Recall that a frequency can be converted to a relative frequency by dividing the frequency by the total number of people or objects being categorized in the table. All right, so a two-way frequency table, we have precinct 1 and precinct 2, and voters on the initiative, people who said yes and no for each thing in each precinct. And then the totals here, and you can see that these add up to 1,500. This relative frequency table shows the percentage of each based on the number in the precincts. All right, so this one has precinct 1 has a total of 60% of the people live there, and in precinct 2, 40% of the people live here. And then you can see out of both precincts, the number of people that said yes was 51 and no was 49%. And again, these total to 1, which is like 100%. All right. So in a relative frequency table, each number in a green shaded cell is a joint relative frequency. So these are your joint relative frequencies, which is the ratio of the number of people or objects in a particular category to the total number of people or objects. Each number in a purple shaded cell is a marginal relative frequency, which is the sum of the joint relative frequencies in a row or a column. So you can see that the 0.33 and 0.18, that gives you the 0.51. So these in purple are your marginal relative frequencies. So that's the sum of the joint relative frequencies in a row or column. Joint and marginal relative frequencies are used for determining probabilities. All right, use the two-way frequency table and two-way relative frequency table shown above. Which number were the frequencies in the first table divided by to obtain the relative frequencies in the second table? What does this number represent? All right, so you can see here we've got all the number of participants, and this is a total of 1,500. So it says the frequencies in the first table were divided by 1,500 to obtain the relative frequencies in the second table. This number represents the total number of voters. So the total number of all voters, not just in one precinct or the other, but all the voters. All right, so what is the probability that a randomly selected voter lives in precinct 1 and supported the initiative? Is this probability a joint relative frequency or a marginal relative frequency? All right, if we go back to the table, we're looking for precinct 1 and supported. So precinct 1 and yes. All right, so if we look at precinct 1 and the number of voters that were yes, that is 33%. 33%. And this probability is a joint relative frequency because that was in green. Okay, remember above it said if it was a green shaded, it's joint, and if it's purple shaded, it's marginal. All right, what is the probability that a randomly selected voter lives in precinct 2? Is this probability a joint relative frequency or a marginal relative frequency? All right, so we need to know how many voters live in precinct 2. All right, precinct 2 would be this whole row here. So this is going to be 40%, and it's in purple, so it's marginal. All right, what is the probability that a randomly selected voter supported the initiative? All right, is this probability a joint relative frequency or a marginal relative frequency? All right, so what's the probability that they supported the initiative? All right, so all of these in the yes column supported the initiative, so it would be 0.51. This probability is a marginal relative frequency because, again, it was in purple. All right, so this is in purple. Again, marginal relative frequency is the purple shaded region. So it's a total of that column. All right, what is the probability that a randomly selected voter was not a supporter of the initiative who lives in precinct 2? All right, so not a supporter and lives in precinct 2. All right, so yes, and precinct 2 is 18%. We want not a supporter in precinct 2. So it would be all of the others outside of yes and precinct 2. So we would have to add up these three totals, or we could do 1 minus 18%. So if you do 1 minus 18%, that gives you 82%. So if you do 1 minus if I turn it on here, 1 minus 0.18 is going to give us the 0.82%. And again, you could add the other three up to get the same thing. All right, that's all for task 1. If you have any questions, let me know. Lesson 17.2, Task 2. Compute probabilities from two-way tables. A wildlife biologist captures, tags, and releases a sample of 2 species of snapping turtles as part of her research. The sample includes 50 male and 62 female common snapping turtles, as well as 46 male and 42 female alligator snapping turtles. All right, so you can see the image of the common snapping turtle and the alligator snapping turtle. All right, so make a two-way frequency table and a two-way relative frequency table of the data. Then find the probability that a turtle the biologist tagged meets each condition. All right, so we want to know if a turtle is male, common, snapping turtle, a turtle is female, or the turtle is an alligator snapping turtle. All right, so the first thing we're going to do is make a two-way frequency table and a two-way relative frequency table. All right, so if you look at the information above, 50, 62, 46, and 42 is the information given. So to put these in a table, all they did was label them. So 2 categorical variables for the table are gender, male and female, and species, common or alligator. All right, so a two-way frequency table is just the information given and then the totals. So we have a total of 200 snapping turtles, and that's a combination of common and alligator. So we have a two-way relative frequency table. So this is just going to be the percentages. So 50 out of 200 is 0.25. 62 out of 200 is 0.31. 46 out of 200 is 23. And 42 out of 200 is 21%. So if you look at the total males, that adds up to be 48%. Total females, 52. If we want to know how many male and female common snapping turtles we have, that would be 56. And male and female alligator would be 44%. And again, these equal 1. That means it adds up to 100%. If you take all 4 of these numbers, that's going to give you 100% of your snapping turtles. All right, so use the two-way relative frequency table to find the probabilities. So the probability of a male common snapping turtle. All right, so a male, here's male, and a common snapping turtle is 25%. Again, that came from doing 50 divided by 200. Female, All right, if we want to know how many snapping turtles are female, we add all the ones in this row or this column up, and that gives us 52%. So that's where that number comes from. And then the probability of alligator snapping turtles. So an alligator snapping turtle goes across this row. So we've got males and females together, 44% are alligator snapping turtles. All right, so how is the probability for the male common snapping turtle obtained? The probability is found dividing by the number by your male common snapping turtles by the total number. All right, so again, 50, the male common snapping turtles divided by the total number 200 is how you get that answer. All right, is the probability for the alligator snapping turtle a joint or marginal relative frequency? All right, so the alligator snapping turtles is going to be in the whole column category, so that's going to be a marginal answer. All right, that's all for task 2. If you have any questions, let me know.